sure will, hopefully. Yeah, I'm live. Yeah, I wasn't sure if you were monitoring, but it's just I've got my circuit, this breadboard in front of me, and I'm reaching across my keyboard. I'm having to reach over to type, and yeah, this new circuit I'm just having to do a lot of thinking about it, because capacitance is a real problem with these kind of circuits. You know, you can get into unwanted oscillations and things like that, you know. So I've isolated it with a lot of ground plane, and I've got to make the gaps reasonably big so I don't get a lot of capacitance. And and I've also added a lot of extra trimmers, which I don't really want to have loads and loads of trimmers, but I thought, well, if I can just find the right values and trim, because you know, doing it on the breadboard is not really suitable because of all the stray capacitance between the long pieces of copper that's in the breadboard. But so I thought, well, I can tag some trimmers in and find the right, set it all up, and then I can take my pots out and put resistors in instead. So I was thinking about doing that. So yeah, it's coming along. I haven't put holes around the edges yet, because every time I put them on I keep getting strange messages about too close to the edge of the board and all this. I thought, well, that's stupid, because they're only pads. Well, I could put mounting on if I want, but yeah. So anyway, yeah, I'm not happy about I've got too many islands now. The green areas are basically islands that aren't connected to anything. But I actually want another island over here, and that one, I had an island there I could use as a heatsink for that Zener diode, and it's now become 0 volts. So and I don't want, no, so it's now become minus volts, and I want it, no, sorry, yeah, it's 0 volts, and I want it as yeah, anyway, I'm getting confused now. It's that this particular island where this text is, this bit here, it's supposed to be that bit's supposed to be isolated from the main 0 volt. Yeah, because that's it. Yeah, this area is 0 volt. This area is an island without connections to anything. Anyway, I'm just going to have to remove all that in a minute. Just get rid of all the copper fill. Right, the copper fill, I've just cleared that out of the way. So I need to put something in there to stop that from becoming connected to 0 volts. So I'm going to stick something in there. So actually, let's put a circle in here. Right, that should help. If I can move that now. If I move that circle up here, I shouldn't get copper flowing into that area now. Oh, what? Oh, it's on, I think it's on the, yeah, it is on the right level, I think. No, it's not. It's on the wrong layer. Right, I need to change that. It wants to be on the bottom copper. That's it. Right, now if I fill this area, that bit should be an island now. Right, I should have an island. Yep, I've got an island now. So now I've got another island over here, which is what I wanted. I've got to disconnect these other islands though from the net. I'll check the chat in a sec, just give me a minute. Right, I think I've got it all sorted out. Let's check, make sure there's no more errors. What? Where's that one now? Oh, wrong one. Error. Where's the error one? Oh, there. Oh, it's because I made that shape there. I can make it smaller. Oh, let's see. Yeah, that'll work. Right, now I've got no errors. So let's have a look at the circuit board now on the other side. I'll refresh it. Okay, that's worked. So I've got the little island there. I was going to solder that to the where the Xeno is, because Xeno diodes can get hot, you see, and I'm using a Xeno just because these inverter chips, this particular one only runs at 7 volts if you go any higher than that, so I've stuck a Xeno in there just to clamp it between the high and the low voltages, which is basically what is it? The Xeno is down here. So I'm clamping the voltage on that chip because it's a CMOS, it doesn't use a lot of power, so the Xeno diode is good enough for that. Hang on. Yeah, I hate using wire links if I can help it though. But you see what I'm doing, what I'm going to do, that Xeno can get warm if yeah, it's not running warm now because I'm only biasing it with 2k resistors on each side, so it's actually running just about right. It's about 300 milliwatts, or 500 milliwatts, sorry. So what I'm doing, once I get this right, I can move this ground plane area. I can zoom in a bit more. I can move this ground plane area, this edge, over to the Xeno now, and it won't matter that it's touching there because it will act as a heatsink. And the other side I can move that area because that's all not connected to it. That green area is not connected to anything right now, so I can go up here. Select all these areas. Oops, I didn't want that. Now I should be able to move all that up to become a ground plane. Sorry, a heat sink. Sorry, I'll move that up a bit. And hang on a minute. Right, let's have a look at the 3D. It should be merged with that now. Let's refresh it. Right, it is, but it's a little bit messy right now. So I've got a heatsink for the Xeno diode. That's a bit messy. I don't like that. I can change that. See. Oops, wrong one. I'll move that in a bit. It's horrible when you're trying to, oops, I've removed that trap, I didn't want to move that. Undo. Doesn't matter if it's overlapping, I just want it to be, it won't be visible on the copper area. If I go down here again, it should look a bit better now when I refresh. That little bit in the middle there, that bit here should fill up when I refresh it. Right, refresh it now. Oh, well, it's not bad. Oops. There's still a bit showing. Okay, Alan. Yeah, I'll be here. I wanna go make some more coffee myself. I honestly, I haven't even made Christmas dinner for myself because I'm on my own. So I didn't even have Christmas dinner this year yet. I'm probably going to cook that tonight. Actually, I'm just going to do sprouts, sausages, and potatoes, and nothing fancy really. I went to bed early last night. I was just tired. Okay, you go and grab breakfast. Yeah, you can't be doing without breakfast. Right, so I'm just going to go and sort this out a bit more. Moving these weird shapes around is a pain in the butt. Right, that should work now. Oh, we've still got a flipping hole there. Oh, it's there. Right. Ah, better. I went and swallowed the wrong way or something. Okay, anyway, that looks better. I put output coupling capacitor on there, 100 nanofarad, which is what I'm actually using on my breadboard. Yeah, it's sad that I've got to really build this board to be able to test it properly, because I'm getting all kinds of weird capacitance on this breadboard. In fact, it's so bad that I can put the coupling link wire on a connection block on this breadboard, on the adjacent one that's not even got anything connected to it, and the signal still comes through. So that's how bad the capacitance is on these things. Is like, actually I've never really measured it, but I did years and years ago. I actually did some measurements, and I think if I remember right, it was something like 500 or 50 picofarads between each breadboard row of connections. It's really bad capacitance leakage on there. It can really screw up your designs if you don't know what you're doing. But I'm aware of it, so that's why I've got quite a nice big gap, between the actual op amp and the inverter, and a lot of ground in between the two. So basically, this whole area is screened because that's ground. It's not a volt actually. It's the dark blue. It's not a volt, so it's in a neutral sort of plane. No, it's not minus, it's not plus, so it's not going to leak any DC through. So it's so important to have a well balanced 0 volt point in between the two. Between the positive signal and negative signals. It's very important to have that. Otherwise, you don't have a linear output. So. I've got more trimmers in there than I really want, but anyway, I'm gonna have to stick some resistors across these as well, because these trimmers are just, until I find the optimum setting. So I'm gonna have to do away with that copper fill area again, probably, until I've got them other resistors in there that I want. That could do to be moved. Stick it down here. Hides there. At least everyone's waking up. I've got a 3, which is better than a duck. Right, so basically I need to, I don't want to be using up all my trimmers. Once I get this thing set right, I really just want trimmers on the output and the input really. And that's one on the input there. 3R3 is one for the input. But I've got to optimize this circuit, and I've been trying to do it on this breadboard and prototyping board, and I've been having all kinds of weird things going on. The whole thing started oscillating all by itself just because it's on a breadboard. Too much capacitance in there. I mean, if you stick a 330 picofarad capacitor to couple the signal, you're fighting against the capacitance on the prototype board as well, because the flipping tracks in between might be 300 picofarad or something silly like that. So you can't really work with picofarads on something like this on a breadboard. It's just ridiculous. So the actual input on here is is R3. So R3 is the input signal to the inverter, and I've put 47k there right now. I think I should put it on this side actually. But that's in series with VR4. Oh, maybe I need to show the values for that. I've stuck 100k in. Oops, oh, flipping heck. Which is going to be balanced because the there's a feedback latching on VR2, and that's going to be 100k too. So that's 100k too as well. Oops. Right. Well, it looks like Hyde's won. Anyway, Alan's going to be back in a minute. He's just grabbing some breakfast apparently, and you know what? I haven't had any breakfast properly yet. I think I'm going to go and grab some breakfast as well. It probably sounds like a good idea. Yeah, I thought that was kind of cool. I'll put the date. December 25th, 2017. I thought, well, it'd be cool to actually have a board that was made on Christmas Day when nobody else works on Christmas Day. I think my circuit board will be probably one of the very few things that were made on December the 25th, 2017. Because nobody else is working on that date. So anyway, I'm going to make coffee. I'll have to show you my new leads as well, haven't I? I'll have to plug this camera in and show you these new meter leads. I'm going to have to plug in that other camera though. Where's that extension lead gone? I'll use that graphic camera. I haven't got the other. I haven't got the other software installed for that other camera. You see, right now, because I restored my computer from my backup, so I don't fancy plugging that other software in right now. I didn't like it anyway. It kept cutting out on me. That flipping what do you call it, camera. It was always blinking out on me. I don't know. So if I get this camera plugged in, I'll go and make myself a coffee. I'll have to start Minicam as well. Just a minute. Hang on. Right, Minicam. I want to make sure that audio device is disabled because it's horrible. You can't hear a word, it's all digital or something. It should still be disabled. Yeah, it is. Right, that USB audio device is disabled. Good. Right. Why can't I get Minicam up? Oh, now it's working. Hang on a minute. Yeah, I want to show you my new leads. In a minute or two. They're pretty neat, actually. My daughter got them for me. Right. Let me select camera input. Right. I'll switch over to camera. Okay, right. They're nice and long. Oops. And a good sturdy wiring. They've got these plugs on the end. Let me just resize my preview so I can see what I'm showing you properly. Now there's a bag of stuff that came with them. Now I'll show you what's in the bag. I've got clip-on leads, so I'll plug these into my probes, and now I'll clip these onto resistors and things. So that's that section. Now if I unplug these like that, I can clip on these ginormous, absolutely ginormous battery terminal clips. Ain't that cool? Oh, mind you, I don't have any big batteries now, but look at that. Eee, cool! I can clip onto anything now. I can clip onto anything without having to use wire jumpers and things. So technically speaking, while this is running, I can clip onto my lamp. Right, there we go. It's reading voltage from my lamp now. Clip directly onto my lamp. No hassle. No more wire jumpers. And just unplug them when I'm not using them. Like this. I use my little clips on my circuit board, you know, from my breadboard and stuff. And yeah, my daughter got me these for Christmas, so I could do with 2 sets though, really, for the other meter as well. But well, we'll just 1 set's enough for now. Hey, I couldn't believe it. It's such good quality. These things even have an 18-month warranty on them. My daughter told me she got a message from the company that she bought them from, saying that there was an 18-month guarantee on these. Well, that's really good. I mean, normally you get a year, don't you? A standard 12-month guarantee, but to actually get 18 months warranty on this stuff proves that they're not Chinese rubbish. Yeah. And I've checked them on the meter. When I short the meter out, when I actually short the meter out on the DC ohms range, I get the same reading. You know, when I put a link in here, I get the same reading as I do when the leads are plugged in and shorted out. So these leads are extremely good quality. I'm not even reading 0.1 of an ohm across these leads. I'll show you how good they are. Stick it on. Well, that's 1 ohms range, right? I'll put these probes together. My meter's off, you see. My meter's reading 0.5, right? take these leads out, right, the leads are no longer in. Now I'm just going to stick a screwdriver directly in there and my nail file directly in the other one. I'll short it out. Now look at the reading. Hang on, can't get a good connection on there. I haven't got a good connection. Look at that, 0.5. Right, I am getting the same DC resistance across these things when I'm shorting them out as I do with my leads, long leads on there. Well, that is brilliant. That means that them leads aren't losing anything on the resistance readings. The meter's a bit off though. I did buy this back in the 1980s though. I've had this meter since the 1980s. It came from Maplin. So I'm not surprised it's a bit out after what 20-30 years? Somewhere. Let me think. 1986, 96, 2006, 2017. That's 30 years. I've had this meter for 30 years. Right, and I'm not surprised it's half an ohm out. That's good. When I first got this meter, actually, I only had it about a week, or was it a month, and no, I think it was about a week, and it quit on me, it packed up on me, so I contacted Maplin and told them that it died on me, and it sent me a thingy, and I sent it back to them. They replaced it free of charge, or repaired it free of charge. That's how good Maplin are. They're really, really good. And I was so impressed. I was so impressed with Maplin at the time. That's when I got the other one, the white gold one, which is a more expensive meter. And this is about, it'd be about the same age actually. Probably a couple of years younger than that other one. Well, it's mucky. It wants a good clean actually. This one's a better range, so it's got a much bigger range. It can read up to 200 microfarads, whereas my other one, the black one, can only read up to 20 microfarads capacitors. So 20 microfarads on the black one. The white one can do up to 200 microfarads. Also, the white one can do up to 4 millihenries. On inductances, and I'm not sure. I don't think the black one can do millihenries. No, it can't. But they both do frequency anyway. They both count frequency. So I mean, I've had them a long time. So that's why I need another set of leads for this one, because the leads for this are just worn out really. This has got a transistor tester in it. So as the black one, they've both got transistor testers in them, which is handy to have. Yeah. Anyway, I'm gonna go and make coffee. So basically, the breadboard, all the test stuff is on this breadboard thing, and there's such a lot of capacitance across here. It's terrible. It's really, really bad. It's hard to get anything tuned on this thing. That's why I need to build a proper circuit board, then fiddle about with it on there. So I'm thinking about putting actual optional place positions for components on the proper circuit board, so I can tune it up, find the right value with the trimmer, then take the trimmer out and stick a fixed resistor value in there instead, so I don't have to use all my trimmers up, because yeah, I'm going to be soon running out of trimmers, aren't I? So I've still got some more changes to do to my circuit before I actually build a board. As it is, I've got 1, 2, 3. I've got 3 trimmers in here, but I need another trimmer down here, but I haven't got room for it. So if I stick it over here, and have long wires going across, then I'm going to have loads of stray capacitance and inductance across everything, and that's not going to make it easy to set up at all. It's just going to interfere with it, because I'll have twice as much capacitance by having it on another set of, you know, there's, I don't know if I can show you this really. Actually I might be able to do about the capacitance across these things. I'll get some leaves. Right, I'm just going to clip onto, I'm just going to stick these move this resistor out of the way. Right, I'll stick this resistor in here, right? There's a resistor right next to it, right? So we've got two spaces between this resistor leg and that resistor leg, two spaces, right? So I'm going to clip onto that one, because the capacitance isn't measured through my leads, it's measured through a different input, so I can't really use my leads for this. I'd like to do. Now stick my meter on 2000 picofarads on this meter now. If I clip onto the this copper thing that's in there, and I clip onto this other copper thing that's in there, we have 15 picofarads between two of those tracks. Now 15 picofarads might not seem a lot, but it is a lot when you deal with micro silicon CMOS chips that actually can be affected by 15 picofarads, you know. So let me move that leg now so that it's actually one hole apart from the other one. I'm just make sure I'm connected properly. All connected properly. I'm still reading. Well, I'm reading 12 picofarad. That's strange. It should be more. Let's disconnect this a minute. It's definitely capacitance between that breadboard. Now let's move it to some different holes. Right, let me stick this over here. I want these wires crossed now. I don't want that capacitor. There's actually a real capacitor there. I don't want that in the way. Move out of the way. And now we should. Oh, I'm on the wrong end of the resistor. Ah! Now. Yeah, we're getting about 10 picofarads across this breadboard. Disconnect the other end a minute. 13. It's going up and down. It's maybe because I'm moving the legs around. Disconnect one end of that. It dropped right down. It's actually gone down to 8, but it's not connected. 3. Actually, it was at 3 just then. Right, it's not connected. So it's 6 right now. So I'll connect that to that. Now we're back at 10. Yeah. If you look at the PDF document, right, for the actual this inverter chip, it specifies that there's a capacitance of about 15 picofarad on the input. So when you're working with high sensitive circuits, breadboards are just not ideal, and you get a lot of stray capacitance, and some of these pads are actually higher than what I was showing you there. They vary. It depends if they've got a lot of dirt down in between the. If you've got a lot of dirt between the inside the holes, that can increase the capacitance quite a lot. You know. So, well, which microphone am I on? No, this is a different circuit, Alan. This is a different circuit. This is for my oscilloscope. I've still got the other board. I haven't built it yet. I've stuck it in that bag over there. That's for a voltage doubler. Oh, the trigger board. No, I haven't. No, this is the trigger circuit is on this breadboard, and there's too much capacitance floating about. I've actually seen oscillations which I don't want to see, and strange effects sometimes just by moving things around. And sometimes you just put your hand near it and it starts oscillating when you don't want it to. So this is why you can't put something like this. I've seen people sticking these little breadboards inside a box on YouTube, and I'm thinking, what the hell is wrong with these people? Why can't they build up off a circuit board, you know? These prototype boards are just that, prototype boards. They're not for an end product. You get all kinds of weird things going on with them, because you get moisture, right, and you get the circuits are very unstable because you get moisture in between the tracks with the humidity and all this, and it affects the stability, and things drift around. And it's something we learnt about back in the 80s, that prototype boards are extremely unreliable. You should never have your end product on a prototype board. It's there to help you to work something out. You try building an RF transmitter on a prototype board. Impossible, because you'd get so much RF coming up the resistor legs, and so much capacitance between the tracks, you would end up with the whole circuit would feed back into itself. And I've tried it. I've actually tried building RF circuits on a breadboard. I've actually got a few circuits. Now, I made a stereo encoder years and years ago. I'll show you it. I've still got it here. This is a stereo encoder, but there's 1, 2, 3, 4 chips missing out of it. So there's 1, 2. I actually nicked all the components. This is a stereo encoder that me and my friend Richard made, and it's got the 90 kHz pilot tone. Right, this is something I made back in the 80s. There's a regulator. It's just piggybacked on the board there. 90 kHz pilot tone. That's the mono 38 level trimmer pot there. Right. Actually, I could salvage these trimmers out of it. Actually, I might do that, because this is something we did this for a stereo. We did this for a stereo transmitter. I love this little switch here. This was turning the stereo pilot tone on and off. These little switches here. The switch still works. Got a thermistor. This is a thermistor for temperature compensation, because they used to drift a little bit, so we had to put a thermistor in to compensate. This was the audio input, left and right channels. It's stereo, so there was that's the left channel, that's the right channel. There was an op amp in here which I've taken out. I salvaged it, and that was the, oh god, I can't even remember now. It's so long now since I've used this thing. That was the 38 kHz. It's written on the board. Left plus right multiplex chip. That was it. Split the. We had left and right. Then you have 3 channels actually. You have the stereo left and right. Then you have a third channel which is your mono, and it divides the frequencies. Then it goes on to the next stage, which is the actual. You know, it's so long I can't remember. Well, anyway, there's a date on the bottom of the board when I made this, and it's the date on it is 1990, February 1990. Me and my friend Richard worked on it together. He actually did most of the design work for the circuit, but I designed this particular board layout because he's a clever kid, you know, he was clever. And I found it the other day. I was going through my old junk and I came across it, and it's Paxlin actually. This board is made out of Paxlin, it's not made out of fiberglass. And it's quite big. Because most of it was discrete. There's a lot in the stereo encoders. That if you go on the internet, you can look up stereo encoder circuits, and you can get them all on one chip now. You can actually buy them online as one microchip now. This was all discrete mostly. There's 4 ICs in it, and I just can't remember. I mean, 1990. We're talking about a long time ago now. I mean, I just can't remember now. But I'll tell you what, I might salvage some of these trimmers out of here because they're not really being used. That's the 47K, which will be handy to use. That's 42K, 47K. I've got a lot of 47Ks in here. What were the blue ones? Can't remember now. As I say, there's no point in keeping it really. The components themselves are useful to have. I can't remember what the values of these trimmers are. Okay, Alan. Yeah, I've had so many problems with proto boards. There was a time when you built something right on a proto board and it was working perfectly right. You made an exact duplicate of the circuit and everything, and you built it all onto a circuit board, and it wouldn't work. And you think, what the hell's wrong? Why won't it work? It was working on the proto board, and it's because there was capacitance on the proto board, which actually made it work. But when you stick it on the circuit board, that capacitance wasn't there anymore, so it wouldn't work. And also the reverse is true. Sometimes you can't get something to work on a proto board, even though you follow the schematic that somebody's put online, for example. It won't work, and then you build it on a circuit board and it works. So there's all these weird things that go on, you know. Anyway, I'm going to make coffee. It must be, I don't know, 4 hours since I last had a coffee. Thanks Hyde about that. Yeah, the leads do look great. I'm really happy with them. I was getting so tired of leads which weren't making proper connections, and I got these replacement leads previously. They must have been Chinese, because you'd move the leads around and the resistance would go up and down. It was really frustrating, because you didn't know if you were working with a faulty component or bad leads. That's the problem. You have to have good leads. It's the most important thing. Many people don't know how to test a transistor manually. I'll show you how. Not everybody knows this, but right, when you want to check a transistor, I'll get my other breadboard, because the legs will be pointing the wrong way. Right, let's just I'll stick it in here somewhere. Right, what you do to test if a transistor is working is you put it on the diode test. You want to check to see that the base and emitter, let's move this, if you can see this properly, hang on a minute. Right, I need to bring this camera a bit nearer. Let me just get this a bit nearer. Copy's good. Right, if we get this so that you can see the transistor as well. And the meter needs to be seen. Just a minute, see if I can get this in the right. Move that. Right, okay, you can see these transistors, can't you, down here on this one. Right, first thing you need to do is find out which is base, right? So we're going to stick the ground, sorry, the negative lead on the emitter, which should be the emitter, right? Now I'm going to find the base. Get this in. Have we got that in the right hole? The easiest way to test if a transistor is good or not, right? This is a PNP. Okay, it looks like a PNP. Right, what you do is you put your this is a, oh, it's disconnected again. Right, that's between base and emitter. The other side base and collector. Okay, right. So we've got 0.708, right? On the emitter we've got 0.712. Now how do you test to see if a transistor is actually switching on and actually working? Well, you keep the probe that's on the emitter, and you get your other probe and you first connect it to between base, well, you go between collector and emitter, and there shouldn't be any reading, right? There is no reading between collector and emitter at all, which is what you would expect. Now we put the probe between base base emitter, and you at the same time you short out base and collector with a probe, so that the probe is in contact with both the base and the collector at the same time. When that happens, the resistance should go down, because that means that the base is turning on the transistor. So let's short out base and collector. Right, I'm shorting out base and collector, and the resistance has gone down to 0.642. Now let's just back off the probe so it's just on base and emitter, and the resistance has gone up. So 0.712 when it's base emitter. I'm going to short base and collector together with the probe, and so it's conducted through both base and collector at the same time. The resistance drops to 0.642, so we know the transistor is good. That's how you test a transistor with a diode tester. Anyway, I thought you might be interested in knowing that, because that saves you an awful lot of hassle if you don't have a transistor tester. Not everybody does, but if you don't have a transistor tester, that's how you test if a transistor is working or not. So first of all, you make sure that the collector and emitter is open circuit, because it should be when it's turned on. Because this is a PNP I'm testing, I'm using the black probe on the collector right now, black probe on the base, and the red probe is on the emitter because it's a PNP. So that's 712, and then short the base and collector together with the probe, where I connect to both of them, and it drops to 0.642. So that's how we do that. Been doing that for years. It's never failed me. Oh, I'm hooked up now. What have I done? Oh, there we go. And also you can test things in circuit with that method as well, provided that the transistors are not turned on too hard already. What's AT sharing? My god, that's a long link. I thought it was 6 links there. I'm not quite sure what I'm looking at. AT, what the heck is, what are you showing me? It looks like you've got something hanging on by clothes pegs. You've got a monitor hanging by a clothes peg. It looks like there's a pair of scissors hanging in mid-air. I'm not with it. I'm not with it. Hang on. Oh well, I don't know what that is. Oh, is it his new laptop? Ah, right, it's showing us his new laptop. That must be what it is. The first picture wasn't very good, this one's a lot better. What's the close peg for? Unless that's to hold the camera. Nice. Right. Oh, I see. The LED strip. Now I'm with you. Sorry, I was trying to figure out, because when you see lighting, generally speaking, you sort of take it for granted. Let's have another look. Oh no, I've got it right. So the lighting above the laptop is what it is made. Ah, cool. That's good. Very good. Yeah, I kind of haven't been paying much attention the last few days because, yeah, I've been trying to drown myself in something because Christmas is not a good time for me without my mum, you know. So I'm just trying to keep my mind occupied. Anyway, I need to go back to this circuit board. So I really want to put some resistors, which is going to be easy because there's plenty of space. So I need to add some more resistors to these VR4 and VR2, which will become static eventually. VR2 and VR4, so let's go to the schematic. Right, I need to copy another resistor, I need one. Right, copy that one. I need a resistor over here. Where's the other one? VR2, VR4, where is it? I lost it now. Oh, there it is. Right, so I need another resistor over here. As a matter of fact, I think a better way would be to put that resistor right across R3. So let's have a look. There's R3. Oh, maybe not. It's going to cause me some issues. No, actually, no, I won't need to, because once I find the right value with that VR4, it means I just have to put the right value resistor for R3 and then just put a jumper link across there. So I can leave that one as it is. But still, I don't know, I think having two resistor slots is better than one, because you can fine tune it. If you've got a really odd value, like something like, let's say it was something like 21.5k or something silly, you could put a 20k in, and you could put a 1.5k in as well to get the exact value. So yeah, that's always good to have an extra. Yeah, some of these oscilloscopes actually use that. They're very, very precision values. So if I go back to my schematic, and if I have another resistor in there, I need to move that down a bit. I think it'll fit in here. Let's rotate that. I want to put plenty of options on this board because I don't want to have to redo the board. Let's see. Oops. Right, so if I have this on there, well, it's in the wrong place now. Oh, that was in the right place, silly me. Okay, so then if I find the right value with the VR4, I could substitute it with R13 at some point. I need to make sure that's optional. Let's see. I need to add a value, something in here, note. Oh God. I'll do that. Oops. I don't like that. It's getting a bit messy over here. I need to move that somewhere. Well, it's not too bad if I move that over here a bit. That'll work. Where's that other resistor? I need to do this one as well. Oops. Oh, go on there. Why won't it connect? There we go. Right, I don't want to use up all my trimmers, you see. And basically I need to remember not to stick a resistor in there unless I need it. So I'm sticking optional on there. There's another thing, if you put two resistors in parallel, a trimmer and another resistor, you can actually get much finer tuning. I don't know if you knew that, but if you put a resistor in series, you get in series with a trimmer, you get less adjustment. But if you actually put a resistor in parallel, provided it's not too low a value, you can actually get more fine tuning. Well, it halves the value really. I mean, if you've got 200Ks in parallel, then it becomes 50K. So by moving a 100K trimmer either way, you actually get a finer adjustment. Because I noticed that with some of these adjustments on my board, it's very twitchy, it's very sensitive. Right, I need to forward those changes now. I'm probably going to have to get rid of my copper fill area. I'll get rid of the copper fill area now and bring these resistors into the equation. That one's the wrong way around. Rotate that. Bring this one down. Let's see, where's that one? This one will fit in nicely just underneath there. That VR is in the way now. So is that one. I'll move them over here a bit. My writing's upside down as well. Oh. Right, let's get this one straightened up. Come on. Why is it being awkward? I want to get a straight line if I can. It's jumping in big steps. I don't know why it's doing that. Right, now I'm going to route it. I think I've got it about right. I'll stick this underneath. No, actually no. Right, I'll just route these connections now. Make them a bit thicker. That's better. Well, that track needs to move a bit over here, otherwise I'll never get my ground plane to go in there. I think I'll stick that just there. How that one? Just there. I think it's about right. I want the same height if I can. Okay, right. Time to fill with copper again, and I hope my little circle stops that. That fill from going in there. Let's find out. Well, copper. I want 0 volt forward. Oh, cool! I've still got my ground plane area. That's worked. Let's have a look at the 3D. To refresh that. Well, that's good. Don't know why I bother with that camera right now. I need to get rid of these islands that are probably still connected to the net, so disconnect that from the net because it's not, otherwise I'll get errors. Because I set the ground, the port area to be not volts, well, including the areas that are islands, and it'll give me errors that they're not connected. Well, they don't need to be, so I'm just going to remove them from the network of connections. Right. So that also wants to be connected to, wants to be heat sinked to that area, so I'll just drag this down again. Drag this one up. Because I want that to act as a heatsink, you see, to cool that Zener down, just in case it does get hot, but it shouldn't do. But oh God, poor AT, I hope he's alright. Well, let's hope it's not, he doesn't get an infection or anything. Right, I need to move that in a bit. Move that one in a bit. Move this one up. Right, okay, that should work. Let's have a look. Right, this diode here should be right in the middle there. Should be grounded now. Sorry, heat sinked. Right, refresh. Yep, it is. Yeah, cool. That's good. Right, let's go back to the. I'll just close this reading. Actually, I'll rotate that around. I want to see where all the resistors are. Yeah, they're good. Oh, I want optional to show up. How can I do that? I want that to show up as optional. If I can, yeah, there it is. Oh, I'm going to have a clash with that writing I put there. I'll move that somewhere else. Oh, that's on the top silk screen. Yeah, well, the other stuff is as well, so I'll move it up there. This is going to be a problem. Maybe. No, I'll leave it there. No, it's too near that. Hang on. I don't like that. I'm going to have to move this out of the way somewhere else. I think actually I can stick that up at the top. I'll stick it over here somewhere. Right, if I stick that up there, move that R4. Can't get it to it now. Right, I'll stick this over here. I'll make it smaller. Don't need to be that big. I think 70 should do it. Okay, that's going to work. That's a lot better. Those resistors are put in there if there's no trimmer in there. You see? Actually, maybe I should put fixed actually. I'll put option fixed or something like that. That's just going a bit too. I need to do. If I get it on 2 lines, can I do that? No, it won't let me. Well, I think it'd be better if I just put fixed. I'll know what it's for. Just when you print these boards out, everything's backwards and you get confused about what's where. Actually, I shouldn't have the value in there if it's a fixed value, because I don't know where it's going to be yet, do I? So the value should be removed. I have no idea what it's going to be yet. Right. Once I find it out with the trimmers, then I'll stick a fixed value in there. Okay, let's check for errors. Oh, now what? What? It's moaning because I put those shapes across onto there. Well, that's fine because I want them on there. What the heck? Stupid program. Oh, I know why I didn't add it to the net, did I? Aha, that's why. Net is right, so add that to that net. And find out what this net is. I've forgotten. Net. And add that one. And that to the net. Should make all those errors go away. Right. Yeah, they've all gone now because that's part of that net anyway now. That should be the same net, N0033 as that one. N0033, yeah, that's correct. In fact, I can move that over a bit more. And what else do we move? Oh, that can be moved a bit. Oh, that's good enough, I think. Right, let's refresh and have a look. Yeah, it's looking better. Yeah, I haven't watched one video. I have not watched one video all Christmas. Well, since well, I probably watched the YouTube. Oh, I did watch some YouTube videos. I watched that Keith Rucker this morning, but I mean, I haven't watched a movie all Christmas. I've got plenty of screening between the two sections, that's good. I don't think I need that little island on that op amp. Yeah, I'm going to knock that out. I think I don't want that island in there really. Could cause feedback. Oscillation, I mean. I think I'll move that text over there a bit. I'll just move it up there a minute. It might be better over here. Maybe. No, maybe not. I don't know. Well, that can move down a bit. That's alright, but okay. I keep forgetting if I put IC sockets in, it's going to overhang on, and it's probably going to cover up part of that writing anyway. I'll move it underneath, that's probably better. Better. My grandma used to tell me to say it properly. That will look better down there. Yeah, that looks better down there. Oh, I know what else I need to do. You know what's really annoying me about Alex Jones? I was listening to him earlier. I mean, it's Christmas Boxing. Well, it's Boxing Day today. Well, Christmas Day, he recorded a show that's basically slagging off people who claim in America who don't want to work, who basically enjoy being on benefits. And I thought that's very low below the belt. Why couldn't he put something on about people who are struggling to make ends meet, who want to work, who can't work because they're sick and disabled? But instead he goes on the opposite side of the coin and he's slagging off people who claim they don't want to work. So to me that is very below the belt against all those people who genuinely are sick and can't work. That is why people in wheelchairs get attacked, because of that kind of attitude, and it really annoyed me listening to that. And it makes a lot more sense now, because I messaged Paul Joseph Watson, his great big buddy over in the UK, saying, why doesn't Alex Jones ever talk about the sick and disabled people who are ill and can't work, people who have got fibromyalgia, people who are disabled in wheelchairs? And Paul Joseph Watson never even replied to me. So I'm kind of very annoyed about that, and I'm starting to think that he's on the wrong side of the fence. Christmas is about giving and helping people. It's not about slagging people off. I think I've got my spacing pretty good. There's a few bits which look a bit, yeah, our C2's look a bit high. I could move that down a bit. But I'd have to get rid of all my copper fill and redo that. No, actually let me think, what is C2 anyway? I don't know what it is now. Rotate that a bit. No, actually C2 needs to be quite a way away from C5. Yeah, C2 wants to be quite a long way from C5, otherwise I'll get feedback, because C5 is the input, C2 is the output of the op amp. So let's have a look. Yeah, they want to be kept apart, otherwise I'll get a feedback problem. Yeah, in fact C2 and R9 are very close together. I don't really like that idea there. It's shielded with that earth throughout with a 0 volt though, but you know what? I'm going to reposition C5. So I'm going to get rid of all this copper fill again. I need to move. I'm just going to get rid of all this on here. Hang on. Unroot that a minute. Oops. I hate it when it does that. I need to move this. I want to move that down a bit. Move it with the track still attached, but it's going to be messy. Let's see. I'll sort this out. Hang on. Alright, I'll reroute that. I'll reroute that one. In fact, I'll move that one over a bit. That's not a volt, so it's screening it anyway, so that's okay. Reroute that. I'm going to redo this one. Right. It's just important to get isolation right. Well, that's not a volt, that can actually go between that resistor as well. So I'm going to get rid of this bit. I'm going to get rid of this. Can't seem to get it, there we go. Get that and that. Unroute that. I don't want that flipping. I'm going to copy this. I'm going to block that route from going through there. I'm going to stick this in temporary so it doesn't auto route through there. Re-auto route. Oh, it won't go around it. Ah, it's because that one's moving a bit more. Oh, that's no good. Hang on. Oh, it won't move. Ah. Oh, that's no good. Hang on, I'm going to get rid of this in a minute. Just a minute. Right. Now let's auto route this one. If it will go around there, should do. Should be able to get through. I can do it manually anyway. Oh, this is stupid. Where does that go? Okay, I'll just take that line out. Right, re-auto route that. If it will. Ah, where's it gone? Well, that's stupid. It's gone all the way around there. Still works though, but it's in the wrong. I don't want it going all the way around there. Well, it actually probably would be better doing that. I'm going to do it manually. Track. That looks better this way. There. That looks better. That can... Oop! I need to cancel that now. Get rid of this thing again. Oh! I didn't want to delete all of it. Blew me neck. It's selecting all of it. I'll have to just select that. Deselect that. Okay, that's gone. Right. Optimize nets. Okay, that's good. Yeah, that looks better. Because my input doesn't want to interfere with the output. You see, the output's coming out on pin 1. I can move this down a bit now and get rid of this track a minute. Oops. Okay. Shubas is back, yay! Right. Well, stream's been going on about 2 hours. I think I'll save it, stop it and save it for now. I get this video files get too big. I really need to go and cook some food. Proper food.